I wish you a very good morning to all of you with full energy, with full enthusiasm. We are going to start a new topic today, a very important topic from the microbiology we are going to discuss today. That is sterilization and disinfection. So we will be discussing the important topic today, that is sterilization and disinfection. You get many MCQs from this topic. Take my words, in your all competitive exam, whatever you are targeting for, are you targeting for NEET PG or FMGE or NICT or USMLE PLAB, whatever, you get many MCQs on this topic. And this topic is, although easy, small topic, but very tricky questions come. So we will discuss it one by one. Can we start? Can we start? Let me share my screen with you. Let me start. Okay, give me a thumbs up. Okay, good morning everyone. Good morning. So let's start it. So we are starting the topic that is just a second, sterilization and disinfection today, an important topic from the microbiology. So first let me tell you the difference between sterilization and disinfection. Do you know what is the difference between sterilization and disinfection? For example, I am having an article. For example, let's take the article this pan. Let's take the article is this pan. I want to sterilize this pan and I want to disinfect this pan. Is there a difference between the two statements? Is it make a sense? Yes, there is a difference. There is the difference. Let me tell you what is the difference. If I say sterilization of any article, for example, this pan, there are 4 types of microorganisms. Listen, bacteria, virus, parasite, and fungus. And bacteria forms spores. You know, bacteria form spores, which are most resistant to kill. Now, this article contains all 5 on it. This pan contains bacteriaceous, virus, parasite, fungus, including spores. Now, if I want to sterilize this article, I want to kill all 5. I want to kill all 5. I want this article should be free of bacteria, free of virus, free of parasite, free of fungus, including free of spore. If this article is free of all microorganisms, if I have killed all the microorganisms present on the surface of this article, including the spores also, I will say this article is sterilized. Sterilization is 100% free of microorganism. It is 100% free of microorganism, all microorganism including spores. So sterilization is sporicidal. It kills spores also. Please understand, it kills spores also. So that is the first thing. Now second thing is disinfection. Disinfection. If I say I want to disinfect this pan, disinfect this article, any article. So here the 4 microorganisms, bacteria, virus, parasite and fungus, they are not 100% killed. They are reduced in number. They all are reduced in number. They all are reduced in number. They are never zero here. They are reduced to such an extent that if I touch this article, I will not have any major infection. So they will reduce in amount. They will be in very small, minute quantity, but still they are not zero. They are not zero. So here, all the organisms are present, but they are in small quantity that even on touching the this article, you will not have any infection. But it never kills spore. It is not sporicidal. Spores are surviving here. The spores are surviving here. So sterilization kills spores also. Disinfection never kills spore. Sterilization is sporicidal. Disinfection is not sporicidal. In sterilization, all the microorganisms, zero. They become zero. The count becomes zero. They all are killed. The article becomes 100% free of microorganism. But in disinfection, it is never zero. It is never zero. The count is reduced. Say yes, everyone, give me a thumbs up. Got it? You got the difference between sterilization and disinfection. So which is better? Of course, sterilization is better. Sterilization is much better, but you know, it's difficult to achieve. So this is the definition of sterilization and disinfection. You can understand. I hope everyone got it. Yes. So sterilization in which the article is made free of all microorganisms, bacteria, virus, fungus, parasite, including the spores also. So basically it's complete absence of microorganism. Sterilization. But what about disinfection? What about the disinfection? Here we are destroying the pathogens which are capable to cause the infection, but not necessarily the spores. Here the microorganisms are not killed, but they are reduced in number to such an extent that they no longer are harmful for health. Okay, so unlike sterilization, disinfection is not sporicidal. So I hope everyone got it. Now, let me give you one more concept. What are antiseptic? Have you heard this word? Of course, we all use antiseptics. Antiseptics are the chemicals. You know, these are the chemicals which we are applying on the human tissue. So on the hands, on human tissue, just suppose there are microorganisms on my hands. My hands are contaminated. My hands have bacteria, virus, fungus or parasite. So I'm using a antiseptic. So antiseptic is such a chemical that will kill the microorganism, but it is not harmful for human tissue. That's why we can use them safely. So these are the chemicals which can be applied safely on the human tissue. Hannah, they do not cause any harm to us, but they do not kill the bacteria necessarily. They inhibit the growth. Hannah, they inhibit the growth of them. Okay, so these chemicals are known as antiseptic. So till now I taught you three important concepts. I taught you what is sterilization, I taught you what is disinfection, and I taught you what are antiseptics. Yes, definitely I will take the session on autoclaves also. One by one we are scheduling the sessions. Okay, there are many topics pending which I have to take one by one. Anyways, let's concentrate on this topic. So let me tell you the methods of sterilization. We got the definition. I hope everyone is aware what is sterilization, what is disinfection, what are antiseptics, and you can tell me the differences between them. Antiseptics are the chemicals. These are not necessarily chemicals. Okay, now sterilization. Let's talk about the sterilization. What are the methods of sterilization? Now, there are two types of methods, physical and chemical. So physical methods, we are having various methods. The most important among them is heat. I will tell you heat in detail. I'm sorry. Among the physical methods, we will see heat in detail, heat and radiation. These two we will see in detail, and among the chemical, we will see a little detail of all of them. So let's start the physical method of sterilization. In the physical method, I want to teach you the heat. The ultra important method of sterilization is heating. So let's see. This is the diagram of the heat. This is the various type of heating which we can use for sterilizing various articles. So we can use two type of heat, dry heat and moist heat. What do you mean by moist heat? By moist heat, I mean the steam. Have you heard about steam? What is steam? Steam is, it is heat. It is a form of heat, but it is the vapors. It is the vapors which are arising from boiling water. Okay, so we will call it moist heat. Hannah. So we have dry heat, we have moist heat. In the dry heat, we have only 4 methods. 1, 2, 3, 4. We will see the details of all of them. I want you to learn the definition of each of them. I mean to understand and basically learn the examples of each of them. In the hospital, which article is sterilized by which method? You have to learn the examples. Your maximum MCQs will be on the examples. Got my point? Got my point? Among the moist heat, we will divide them in 3 categories. Now, if we are heating the water below 100 degree, we are boiling the water at 100 degree, at 100 water boils. And if we are boiling the water above 100. So these are the 3 different methods. In the moist one, we will discuss all of them one by one. So basically, whatever is written on this page, you can see 4 methods in the dry, and you can see 4, 5, 6, 7, 8 methods in the moist. So I will discuss all 4 in the dry and all 8 in the moist, one by one. So don't learn the definition, just understand the method. What is the difference between the method in each of them? Learn the temperatures in each of them. And most important, learn the examples. Maximum questions you are going to get on examples. Say yes. Say yes. Can we go ahead? All the PDFs, Jitendra, are already available. This session also, it's already uploaded. Okay, so there is a link which is given in the chat box. Right now, you can also go on the link. It is a pinned link. So if you click on that, you will get all the notes of all my YouTube sessions, which I am taking live here. Okay, so of all the subjects, you are going to get it. Okay, anyways, come on this. So we are starting dry heat. In the dry heat, 4 methods are there. What are the 4 methods? Read the names first. It is red heat, flaming, incineration, and hot air oven. So we will discuss them one by one. Okay, let's discuss this. So let's start dry heat. Dry heat. Let's start red heat. What is red heat? You know, there is a rule. The rule is that, have you heard about metals? Whatever metal you take, there are many metals. For example, iron, copper, aluminium. If you're taking any metal and you are heating that metal, you are heating that metal in a Bunsen flame. You are heating. One point will come. That metal will look red in color when it is too hot. When it is visibly with our eyes, it is looking red in color. We assume, just suppose it is a metal, although it's a plastic, but assume it is a metal. Assume it is iron, copper, any metal. I'm heating it in Bunsen flame, heating. One point will come, it will look red to me. Externally only, it will look red to me with naked eyes. At that point, I'm assuming it is sterilized. I mean, when it is looking red now, all the bacteria, virus, fungus, parasite, including spores, everything is killed when it is looking red. So this method is known as red heat. Simple. Name itself is depicting its meaning. Red heat. So on heating, the metal looks red. So here the objects are held in the Bunsen flame. Can you see? So this is a metal. We are putting it in the Bunsen flame. You can see. We are putting it in the Bunsen flame and it will look red. When it will become red, we are assuming it is sterilized. This method is used for incineration loops and wire. In the diagram also you can see this is the incineration loop. You know, it is used. Incineration. It is the inoculation loop. Okay, so it is used for inoculation. So the tip of the inoculation loops are sterilized by this method. You understand? What is inoculation loop? Just suppose this is the sample of my patient. This is the specimen of my patient. It can be blood, it can be urine, it can be CSF, it can be stool, it can be saliva, it can be anything. It contains microorganism in that. Okay, it is containing the bacteria in that. And this is my culture media. This is my culture media. What I want to do? I want to transmit the specimen, few drops of specimen on the culture media so that the organism grow. I want to do so. So how should I do? I need something. I cannot use a spoon, so take one spoon from here and just pour it here. So I need something to transfer the specimen from the test tube into the culture media. So here we use the inoculation loop, which is required for inoculation. So just suppose it is a loop-like structure. It is made up of platinum or nichrome. It's also a question. Okay, it is made up of platinum or nichrome. Okay, it's a loop-like structure. It's a wire with a loop. Okay, now you are dipping it here, taking the material from here, and after taking it here, you are just inoculating here. So you are transferring the material like this. But imagine if the tip is not sterilized, if it is already contaminated. So you, instead of transferring this bacteria, the bacteria which are present on its surface, they will get inoculated. So before doing the inoculation, we have to sterilize the tip of the inoculation loop, and that we do with this Bunsen flame. That we do with red heat method. I hope everyone got it. Say yes. So it is always necessary. I'm having a specimen. Imagine this is specimen of my patient and this is my culture media and this is my inoculation loop. So before transferring the material from the test tube into the culture media, I have to inoculate the tip so that actually I'm transferring only those bacteria which are present in the culture, in the test tube, in the specimen. If it is contaminated, I do not want false positive results. Got my point? That's why its sterilization is necessary, and that we do by red heat. Say yes, give me a thumbs up. Got it? Now the second method is the flaming. The second is the flaming. Okay, red heat is done. I'm coming on the flaming, the second method. In the flaming also we use the Bunsen flame. Here also you can see this is the Bunsen flame and we are heating the object. Here the object is not necessarily metal. Okay, and we do not wait till it becomes red. We just heat it superficially. So that is flaming. It is not a good method. The red heat is the best method. Here we are waiting till the object look red in color. Here we are not waiting till it look red. We are just superficially heating it. The method is same. So objects are passed in the Bunsen flame without allowing them to become red. Okay, it is used for slides. Not simply for slides and all, but not a good method. We don't recommend it. The third method we are coming is incineration. The third method is incineration. Incineration simply said is fire. Fire, है ना? You put fire on anything. If you put anything in fire, that thing converted into ashes. You know, हिंदी में कहूँ तो राख बन जाएगा. किसी चीज में फायर लगा दो, आग लगा दो, तो वो चीज कन्वर्ट हो जाएगा राख में. राख is ashes, है ना? So basically we are destroying that object, that article. For example, this is the article and I'm putting it in an incinerator. Incinerator is the instrument in which high temperature, 2000 degrees Celsius is the temperature. So there is a fire actually. So we are putting this article inside this incinerator so it will catch the fire and it will convert into ashes. Because whatever microorganism present on this object, on this article, the bacteria, virus, fungus, parasite, spores, by killing them, we cannot use this article. So we have to destroy it. We have to destroy it. So in incineration, the article get destroyed basically along with the microorganism. All the microorganism will get destroyed, but this article is also destroyed. After incineration, you cannot reuse it. Got my point? So this method is known as incineration. Say yes. Say yes. Okay. Thank you so much for your compliment, Sanan. Thank you so much. Okay. So this method is incineration. Do you have any doubt here? Otherwise, give me a thumbs up. I can see your chat, I guess. Give me a minute. Okay. So this method is known as incineration. So here the infective material is reduced to ashes by burning. We are burning the material inside an instrument known as incinerator. So for what it is used? It is used for two things. Number one, the soiled linen. Soiled linen. What do you mean by soiled linen? Linen means any cloth. For example, I'm wearing an apron, I'm wearing a OT gown, working in my hospital. Today I'm having a dress or anything. I'm working in a hospital. So the whole day I have worked, and in the evening, in the night, whenever I'm leaving the hospital, I should change the OT gown and put it for autoclaving if it is not contaminated with blood. But imagine I am operating a patient and there is a squeeze of blood on that. So my apron, my OT gown or my dress that get contaminated with the blood of the patient. Now I will call it soiled linen. It is no more a simple linen. It is a soiled linen. Soiled means the linen is contaminated with any body fluid. Any body fluid. Usually it is blood. It can be stool of the patient. Now, just suppose it is a patient and the patient is having urinary incontinence. So the patient is passing the urine in the clothes only, or the patient is having incontinence of the stool. So patient is passing the stools in the clothes only. So that clothes cannot be washed and reused. No. Just incinerate it. Just discard it, incinerate it, burn it. Okay. So any linen which is contaminated with any body fluid in human. It can be saliva, it can be any body fluid. If it is infective, just incinerate it. Okay, it is known as soiled linen. So blood containing cloths, the cloths which are contaminated with the bloods, usually we incinerate them. Okay, so all the soiled dressing, soiled linen, number one. And number two, animal skin. Animal skin, it's not written here. Animal skin. Animal skin is there. For example, the leather is made of the animal skin. It has to be incinerated. So these are the two examples in the incineration. The fourth and the last which we are taking here. The fourth and the last we are taking here, ultra important, is hot air oven. What is hot air oven? Have you seen this hot air oven in your hospitals, in your laboratories, anywhere? In your microbiology laboratory, you may have seen it. This instrument is known as hot air oven. So let me tell you the principle, the method, the uses, the control of this instrument. Now just suppose this instrument is used for glass articles. Imagine this is made up of glass, although it's made up of plastic, but imagine it is made up of glass. Okay, if it is made up of glass and I want to sterilize it, so what I will do, I will take this pen and put it inside this instrument. In this instrument, you can see in the hot air oven, there are various shelves. Can you see? These are the shelves, various shelves. So we will place the article in any of the shelf and close the door. Just close the door. And we have a thermostat here. This is a thermostat in which you can set the temperature and time. You can. So you have to set the temperature of 160 degree and time for 2 hours. 2 hours is 120 minutes. So please learn 160 degree for 120 minutes. See, you have to learn it. Set the temperature. It's a rule. You have to set the temperature in autoclave, in hot air oven of 160 degree. And you have to set the time for 2 hours. Just do that. After 2 hours, there will be a buzzer. There will be an alarm buzzer. So the process is completed. You open the door, this article, whatever you have put inside that, it is sterilized. Because we assume that at 160 degree for 2 hours, all the bacteria present on this, viruses, parasite, fungus and spore, all 5 are killed, including spores also. So at 160 degree for 2 hours, everything present on this article is killed. Now this article is super sterilized. We can say that. This is the principle of hot air oven. So at 160 degree, here the temperature inside this will become 160 degree. So the heat is generated electrically and there is a fan which rotate the hot air everywhere. So in all the shelves, equal hot air is there. It is not that the upper shelf will get more heat, the lower will get less heat. No. All the shelf will have same hot air because there is a fan. So there is a hot air generated inside this instrument. That's why it is known as hot air oven. This is the principle. It's a method of dry heat. Say yes if you all got it. Say yes. So what is the holding temperature and holding time for this instrument? Ideally 160 degree for 2 hours. But I'm very busy. I don't have 2 hours. I want it to be done fast. Is there a way? Can we do it fast? Yes, we can do it fast. Increase the temperature by 10. Instead of 160, use 170. The time will half. Instead of 2 hours, you require only 1 hour. Okay, if you are using 170 for 1 hour. Okay, but still I'm very busy. Still I don't have 1 hour. I want to make it more fast. So again, increase the temperature by 10 degree. 180 degree. So again, the time will reduce to more half. Okay, so it will be 30 minutes. So ideally in the option, you search for this. If it is given in the option, go for that. If it is not given, search for the second best. If it is also not given in the option, search for the third best. So एक ना एक तो होगा ही होगा options में. You will get a question, what is the holding time and holding temperature of hot air oven? You will be given 4 options like this. So please learn, this is the temperature and time. Learn the principle, learn the diagram, learn the temperature, learn the time. Now tell me the uses. What are all articles we sterilize in this instrument? We sterilize 2. Number 1, glass. Conch, glass का जो भी बना है in a hospital, whatever is made up of glass or conch का, that is all the glass syringe, all the petri dish, all the flask, all the pipette, all the test tube, whatever made up of glass has to be sterilized on this, number one. And number two, you can remove this. Number two, chemicals, oily chemicals, है ना? For example, liquid paraffin, fat, grease, dusting powder पे PYQ है, there is a PYQ, okay? So dusting powder, it's also an oily chemical. If you want to sterilize the oily chemical, this is the best instrument, है ना? So for glass and oily chemical. Surgical instrument, this is the second best, that's why I have removed it. For surgical instrument, the best is autoclave, that I will teach you. But this is the second best. Okay, so learn the two uses. So we have seen the principle, temperature, time, uses. Now tell me the control. What do you mean by control? First understand what do you mean by control. Huh? No, don't increase the more temperature further 190 degree for 15 minutes. No, it's not applicable. Okay, toxic. No, you will get one of the three among the options. The best is this is second best, this is third best. We don't further increase the temperature. No, got it? Now listen. Listen, what is control? So this is my pan. Hannah, it is made up of a glass. Imagine, this is an article made up of glass. Hannah, I want to sterilize it. You will say, ma'am, no worries, no? It is glass, no? There is a hot air oven in our laboratory. Just put it. So this is the hot air oven you can see on the screen. I'm putting it. I'm just closing the door. I'm doing the temperature 160 degree and time for 2 hours. And I'm just closing the door. So after 2 hours, there is a buzzer. When I open the door, how I become sure that this is 100% sterilized? Maybe inside the instrument, the temperature is not achieved. There can be some problem, technical problem, any problem. Maybe the time is not proper. Before that, only buzzer is there. Or any problem can be there. So how I become sure that this article is 100% free of microorganism and I can use it in my patient? Before taking it out, I want to become sure. I want to become confident that this article, whatever glass article I have put or any chemical I have put, it is sterilized. How to become sure? So we have to use the control. So what is the control? What is the control we are using here? So there is a bacteria. Okay. The name of that bacteria is known as Bacillus subtilis. Learn the name of the bacteria. Bacillus subtilis. And there is a subspecies of that bacteria. There is a specific subspecies niger. Say complete name. Say the complete name. The name of the bacteria is Bacillus subtilis and it is having a subspecies. The name of the subspecies is subspecies niger. The spores are available commercially. So take the spores of this bacteria, take it in a packet. Take a packet, put the spores there and close the packet. You will say, ma'am, from where I will get the spores? They are available commercially. So take the spores of Bacillus subtilis subspecies niger in a packet, close the packet and put that packet here inside this instrument along with your article. So I'm having the article, I'm having the packet. I will put both. Close the door. I will put the temperature 160 degree, time for 2 hours. After 2 hours, whenever there is a buzzer, I'm opening the door. Before touching the article, I will take the packet out. I will open the packet. And if I will see the spores are dead or alive. If the spores are dead, the process is successful. And if the spores are alive, the process is unsuccessful. You have to repeat it. You have to fix it. Got my point? Because the rule says that the spores of this bacteria, why we have selected only this bacteria, not others? Why we have selected the spores of this bacteria? Why we have not taken the spores of any other bacteria? Because spores of this bacteria get killed at 160 degree for 2 hours. So when the temperature reach 160 degree for 2 hours, then only the spores will get killed. Otherwise, the spores will not get killed. Say yes. So this control is known as biological control. So if the spores are dead, they are killed, you have become sure the process is successful. And now you can easily take out your article and you are confident that it is sterilized. So this is biological control. But there is one more control. This is biological. There is a chemical control. So there is Brownie's tube available. There is a chemical which is present in a tube. The color of the chemical is red color. It is known as Brownie's tube. Now, whenever you are heating it at 160 degree for 2 hours, the color changes and finally it becomes green. So along with this article, this is a glass article. I'm putting it along with that. I'm putting Brownie's tube number 3. That is red color. I'm closing the door. The temperature is 160 degree. Time is 2 hours. After 2 hours, whenever there is a buzzer, I'm opening it. Before touching the article inside that, I'm looking the color of the chemical. If the color of the chemical is changed from red to green, I become sure that the process is successful and this is my control. I can touch it and I can take it out. Say yes. Thank you so much for all your compliments. Thank you so much. Okay. So wishing you success in your future. Just the only thing I want from your side is your success. Whatever exam you're targeting for, just success in that. Okay. So the complete exercise is for your benefit. Anyways, so let's move further. We are done with dry heat. Hannah, what we were studying? We were studying the methods of sterilization. The best method of sterilization is heating. In the heating, 2 options are available. Dry heat, moist heat. In the dry heat, we are having 4 options. We have seen all of them. Tell me the examples of all 4. What are the 4 examples? Red heat, flaming, incineration, hot air oven. First learn these are the 4 methods which come in dry heat. Now tell me the examples of all of them one by one. Tell me, who will tell me the examples? Example of red heat is inoculation loop. Inoculation loop. We sterilize an inoculation loop and inoculation wire with red heat. The tip of inoculation loop. Flaming, it is used for simply glass slides, but it is not a recommended method. Okay. Incineration is used for soiled linen. Soiled linen. You know what is soiled linen? Any cloth, cotton which is contaminated with human fluid, especially blood. And number 2, animal skin. It is used for animal skin also. And number 4, hot air oven. The 2 uses are glass. All glass. It can be petri dish, it can be flask, it can be test tube, it can be slide, it can be anything. All glass. And number 2, chemical. Oily chemical, including grease, dusting powder also. Everyone say yes. So please learn. You get questions on that. But you know the method of each of them. You know the diagram of each of them. You know the principle of each of them. So whatever question coming, you are prepared. Maximum questions on example. So can I start moist heat? Everyone give me a thumbs up first. Can I start moist heat? Say yes. Are you people awakened? Listening, understanding, enjoying? So coming on the moist heat. In the moist heat, I'm having three type of moist heat. In the moist heat, if I'm heating the water below 100, I'm heating the water at 100, and I'm heating the water above 100. So there are 3 possibilities. Below 100, again 4 methods. Pasteurization, Inspissation, vaccine bath, and LTSF. Among them, the first 2 are important, but we will see all 4. So let's see below 100. Then we will come at 100, and then finally ultra important we will come above 100, that is autoclave. So we will finish all the methods of sterilization by heating in this way. So let's come on the below 100. We have already covered this section, the dry heat. We have seen the examples, method, procedure, principle, everything. And now I am coming below 100. In the below 100, the first is pasteurization. I guess everyone know pasteurization is done for sterilization of milk. The only example here is the milk. You cannot sterilize anything else with pasteurization. Pasteurization is a method in which, do you drink milk? If you drink milk, tea, coffee, we drink milk. No, we utilize milk in our food or something. Okay, so if you are not a vegan. Okay, so anyways, so sterilization of milk is done by pasteurization. Pasteurization is a method in which we are sterilizing the milk. For example, I am having a cup of milk. Now the milk may contain bacteria, virus, fungus, parasite, and spores. So whenever we are doing the sterilization of milk by pasteurization, the spores are not killed. All other things will be killed, but spores are not killed. Please remember, pasteurization do not kill spores. So actually it's not a sterilization, it's disinfection. It's a method of disinfection because spores are not killed here. And one bacteria is not killed. All other bacteria are killed except one bacteria. The name of that bacteria is Coxella burnetii. It's also an MCQ in your exam. So pasteurization do not kill one bacteria. Name that. It's Coxella burnetii. It is the bacteria which is not at all killed in pasteurization. Okay, got it? Number 1. And number 2, spores. None of the spores is killed by pasteurization. So basically, pasteurization kills 90% of the bacteria. It's not 100%, I mean to say. There are 2 methods of pasteurization. Holder method and flash method. Please learn the names. Holder and flash. There are 2 methods. Okay, the temperature and timings will be different. That's it. Okay, both of them are below 100. Okay, the 2 methods of the pasteurization are below 100. So temperature in both of them is below 100 only. In both, either of the method, the temperature is below 100 because pasteurization is a method of sterilization which is coming below 100. You are getting my point? So what are the 2 methods? Holder and flash. In holder, this is the milk. Assume I'm having a milk in the container. This is the milk in a container. I want to sterilize it. I want to pasteurize it. So I start heating it. I started heating it. Okay, I'm starting. So temperature is 63 degree. Here it should be 63 degree. I should heat it at 63 degree for half an hour, 30 minutes. If I'm doing so for 30 minutes, it will get pasteurized. All the bacteria will get killed except Coxella burnetii, but spores are not killed. So this method will be completed at 63 degree for 30 minutes. But again, the problem is same. I'm very busy. I don't have 30 minutes. I want to make it fast. So is this a way? Yes, you will say, yes, ma'am, there is a way. So if you are heating at 63 degree, you require 30 minutes. You require 30 minutes. Okay, but I don't have 30 minutes. So I will increase the temperature by 9 degree. How much? 9. I will use 72. Instead of 63, I will use 72. I'm just increasing the temperature by 9 degrees Celsius. By doing so, the time will reduce drastically. Here the time was 30 minutes. It will reduce drastically. It is only 15 to 20 not minute, second. This was minute, this is second. You can assume the difference in the time. So it will be as fast as like this, It is in just 15 to 20 seconds. So that's why it is known as flash method. It is like a flash of light. It's very fast. So that's why it is known as flash method. So here the temperature is 72 and the time is only 15 to 20 second, not minute. How many of you got it? So you get questions on all these. What is the temperature and time of hot air oven? What is the temperature and time of holder method of pasteurization? What is the temperature and time of flash method of pasteurization? So you have to tell me all temperatures and time for the MCQs you have to learn. Say yes. Got it. Can we go ahead? So this is pasteurization. All the questions on pasteurization will be from this. So questions will be on the two methods, the temperature of each method, the time of each method. You can notice the temperature in each of them, it is less than 100. Okay. And which bacteria is not killed? And the spores are not killed. Now the next method after pasteurization, you can see we are done with pasteurization. Okay, pasteurization is done. Now the next is Inspissation. Below 100 only. It is Inspissation. So what is Inspissation? What is Inspissation? In Inspissation, we sterilize culture media. You know how many types of culture media are there? I will take a session on culture media also. There are various types of culture media. Let's divide them into two. Okay. All culture media will be on one side, except the unstable culture media which contain egg or serum or sugar. Such culture media I am taking on other side. Okay. So I want to sterilize the culture media. So all the culture media except these, they are sterilized by autoclave. Autoclave. I will teach you autoclave also, that is above 100. But the culture media which contain egg, serum and sugar, they are sterilized below 100. In the below 100, they are sterilized by Inspissation. They are sterilized by Inspissation and Tyndallization. You are getting my point? Because they are very unstable. If you heat them above 100, they will get degrade. You are getting my point, what I am saying? Listen, have a look here. Let me explain you. Can you see the three types of moist heat? Below 100, at 100 and above 100. First have a look. Everyone here on the screen. Below 100, at 100, above 100. What I am saying? I am saying all culture media are sterilized by this method. It's above 100. I will teach you that also. It's above 100. But the culture media containing egg, serum and sugar, they are unstable. You cannot heat them above 100. They will get degrade. So you have to heat them either below 100 or at 100. So there are two methods. Inspissation and Tyndallization. Okay, Inspissation and Tyndall. Inspissation is at below 100 and Tyndallization is at 100. These both are for culture media containing egg, serum or sugar. How many of you got it? How many of you got it? Say yes. Say yes. Say yes. Got it? Can we go ahead? So what do you mean by Inspissation? Hota kya hai isme? What do you mean by Inspissation? Listen. So here I am having a culture media. This is a culture media. It is not a normal culture media. This culture media contains egg, serum and sugar. I want to sterilize it. So I will use an instrument. The name of the instrument is Inspissiter. So what I will do, I will put this culture media inside the Inspissiter, and here the temperature is 80 degree. Because it is below 100 now, you cannot make it 100 or above 100. It is 80 degree. And we will heat it for half an hour, 30 minutes. 30 minutes today. What is the day today? I guess today is Wednesday. Wednesday. So today we will do it. And tomorrow on Thursday we will do it. On Friday we will do it. So we will do it on 3 consecutive days. 80 degree half an hour today. 80 degree half an hour tomorrow. 80 degree half an hour a day after tomorrow. 3 continuous consecutive days. You will say, ma'am, ab ye kya pagalpan hai? What you are doing this? Why you are not heating 1.5 hour in one day only? Why you are not heating at 80 degree for 1.5 hour instead of doing it in three different sessions? Why you are not taking a one long session? You may be thinking that. Everyone thinks like that. So there is a principle behind that. Listen. At 80 degree, what this culture media contain? You say, ma'am, 5 things. It may contain bacteria, virus, fungus, parasite, and the 5th one is the spore, the most resistant to kill. So whenever you are heating it at 80 degree, now the first 4 get killed. The bacteria get killed, virus get killed, fungus get killed, parasite get killed. But 80 degree spores are not killed. They are surviving. So how to kill them? At 80 degree, they cannot kill. Now, the first day it's over. All the bacteria, virus, fungus, parasite are killed, but spores are still surviving. Now, after that, we will give a gap of 24 hours. In the 24 hours, we will try to germinate the spores. We will give the time to germinate. Once they will become germinated, they will convert into bacteria, na, the vegetative forms. So we are allowing the spores to germinate. You know, bakri ko marne se pehle khilana pilana. Got my? The same thing. So we are allowing the spores to germinate so that we can kill it on the next day. Got my point? We are asking the spore to germinate. It convert into bacteria. The next day, after 24 hours, again we are heating at 80 degree for half an hour. So if it is converted into vegetative form, it will get killed now. And again, the third session is for any backup, if any residual is there. So this is the principle behind them. Say yes. Okay, got it? Huh? Got it? Okay, so Kimu, which portion of pharmacology you are looking for? One by one, we will take topic wise the complete pharmacology here only on this YouTube channel. Okay, I'm having in many other YouTube channels also many live sessions I take. So today also I'm having a live session in the night from 10 to 12 in other YouTube channel, not on this. Okay, so what is exactly your query? So can we go ahead? So this is Inspissation. What is Inspissation? Inspissation is heating at 80 degree for half an hour daily for 3 days, 3 consecutive days. This is the principle. How many of you got the principle why we are doing multiple sessions in Inspissation? And the use is culture media containing egg or serum or sugar. Egg, serum or sugar. Such culture media, Inspissation. The third one is the vaccine bath. Here it is used for vaccines, for sterilizing vaccines. So just suppose I am using a vaccine. Before vaccine is given to me, it should be sterilized. Okay, so we sterilize the vaccine at 60 degree for 1 hour. Hana, it is below 100. And last one is low temperature steam formaldehyde method. It's not useful. You can leave it. So we are done with these 4. We are done with these 4 also, these 4 also. In the end, I will ask the uses of each of them. You have to enumerate the uses. Method you are understanding. Okay, just enumerate the uses and see the diagram. You can get 3 type of question. Either image-based question. They will give you a diagram and they can ask you anything, the image given of which method or the uses of that. The second is the uses and third is the principle of each of them. The method and the principology of each of them. Okay, got my point? Can we go ahead? Coming at 100. In the at 100, we are having 3 methods. We will discuss all 3 one by one. So boiling. We know at 100 degree water boil. Water boil at 100 degree. The second is Tyndallization and third is steam sterilizer. So we will see all 3 and the examples of each of them. Let's start with boiling. Boiling is the most oldest method, I must say. Huh? How many of you remember that whenever you were a kid, your mother used to give you boiled water? Mothers are very, they are very possessive for their children. No? So they think that boiling is the best method. By boiling, they are sterilizing the water. So my mother used to do so for many years. Okay, Hannah. So the water, before they give the water to their kid, they just boil it at 100, then cool it, then they give it to the kids or the, elderly people, because they think that boiling kill all the organisms present in that and the thing becomes sterilized. They think so. But it's a, it's a myth. Actually, it is not that. I told my mother also, because boiling is, first thing, you have to boil at 100 degree for 30 minutes, at least for 30 minutes. It is not just started boiling and switch off. No. If you're boiling anything, boil it for 30 minutes. Then in 30 minutes, all the bacteria will kill, viruses will kill, parasites will kill, fungus will kill, but boiling never kills spores. Spores are resistant to boiling for whatever time you are heating. You heat for half an hour, 1 hour, 2 hours. Spores are resistant. Boiling cannot kill spores. So boiling is not a good method because spores are still surviving now. So if you are boiling anything, the first thing, just suppose I'm drinking water, I want to sterilize it. I will boil it. First thing, I have to boil it for 30 minutes. Hana, it is not. Usually what we do, just it started boiling, we switch off the gas and take it off that it is boiled. No. Boil it for 30 minutes at least. Okay, so in that also, everything will be killed except spores. Okay, so it is not a recommended method, number 1. So that is boiling. It is the oldest method, conventional method you say. Okay, the second is the Tyndallization. Tyndallization is same as that of Inspissation. Both are equivalent. You will see, ma'am, Inspissation and Tyndallization, yes, both are same. The only difference between them, this is below 100, this is at 100. So let me tell you, this is Inspissation and this is Tyndallization. Here we heat at 80 degree, here we heat at 100 degree. Here we heat for half an hour, 30 minutes. Here also we heat for 20 to 30 minutes. Here also for 3 consecutive days, day 1, day 2, day 3. Here also 3 consecutive days. The principle is same. Just suppose this is an article and I want to sterilize it by these methods. Okay, so it is having 5 things: bacteria, virus, parasite, fungus and spore. So on day 1, On day 1, the bacteria, virus, fungus and parasites are killed, but spores are not killed. So we are giving 24 hours to germinate the spores. Once the spores are germinated, they convert it into vegetative forms. Now on day 2, again on heating, on the same temperature, they will get killed. And if any residual, again we provide the 24-hour interval. And again, at day 3, they are killed. So after day 3, this article is free of everything. Bacteria, virus, fungus, parasite, they are killed on day 1 only. But the spores are also killed. So this article is said to be sterilized. Now you use your common sense and tell me which one is better. Both of them known as intermittent sterilization. Intermittent. You use this word. Intermittent sterilization. So both of them together known as intermittent because we are using consecutive 3 sessions of sterilization. That's why intermittent sterilization, and we are giving 24-hour interval between them. So which is better? Obviously, Tyndallization is better than Inspissation. Why Tyndallization? Because your temperature is 100 now. 180. Just suppose there are bacteria, virus, fungus, parasites. So which temperature is better to kill them? They will kill better at 100 or they will kill better at 80? Obviously at 100. So you know Tyndallization is much better than Inspissation. If Tyndallization is not available, then go for Inspissation. And the use of both of them, to be very specific, please concentrate. Use of both of them is same. All culture media containing egg, serum or sugar. Okay, so listen, my 3 questions. 3 questions. Tell me the way of sterilization for culture media. Okay, tell me the answer. And tell me the way of sterilization, the method of sterilization for culture media containing egg, serum or sugar. What is your answers for the 2 cases? What is the answer? I am asking here simple culture media and here I am asking the culture media containing egg, serum and sugar. Tell me the best way to sterilize them. Tell me the ideal method to sterilize them. For all culture media, the ideal method is autoclave that I am going to teach you now. I have not taught you this. This is above 100. But for the culture media containing egg, serum and sugar, the best method is Tyndallization if it is given in the option. If it is not given in the option, look for Inspissation. Tyndallization followed by Inspissation. Please write it down, learn it. Please. There is a confusing question. So please learn it. Give me a thumbs up on this point. Say yes if you got it. No confusion. Concept should be crystal clear without any confusion. Can we go ahead? So these all are your MCQs. I'm telling you. These all are your MCQs. Okay. Okay, G. Can we go ahead? So this question is straightforward. Answer is autoclave. But for this question, it's a trick. In the 4 options you are provided, you have to look for Tyndallization. If it is given, go for that. Blindly go for that. If it is not given, look for the second best. That is Inspissation. And definitely one of them they will give in the option if they are framing the question. Hannah, got it? Can we go ahead? So we are done with Tyndallization also. We are done with boiling. We are done with Tyndallization. And now I'm coming on steam sterilization. The third and the last one here. The steam. Naam mein hai. So see Tyndallization. See the details of Tyndallization first. Here we are heating at 100 degree. For 20 to 30 minutes for 3 consecutive days. Day 1, day 2, day 3. So between the 2 days, we are providing intervals so that the spores can germinate and on the next day we can kill it. It is used for culture media containing egg, serum and sugar because they cannot tolerate the high temperature. The third and the last method here we are taking is steam sterilization. Steam sterilization. Can you see the instrument? It's a very simple instrument. Okay, see. In this instrument, can you see there is a perforated tray? Let me show you. Can you see this is a perforated tray? Put your article over here. It is perforated tray. It is having holes in that. It is a tray on which perforations are there. For example, this is my article. I will open it, put my article on the tray and close it. And below the tray, there is water filled. Can you see the water? The water is there. Start heating. So whenever the water start boiling, when the temperature become 100 degree, water automatically start boiling. Whenever the water start boiling, you can see this is my article. Let me put my article. For example, this is my article, which I have put on the plate, on the tray, which is perforated. So whenever the water start boiling, the steam is formed, the vapor is formed. And from the perforation, it will come up. From the perforations, the vapor will come up and vapor on the surface of this article, this is the article. On the surface of this article, whatever bacteria, virus, fungus, parasite and spores are present. Spores are not killed at 100. So except the spores, all other things are killed. Bacteria, virus, fungus and parasite. From the steam they are killing. Say yes if you got it. Spores are not killed. Except spores, all the bacteria, virus, fungus and parasite present on the surface, they will get killed from the steam. What is the temperature of the steam? It is 100 degree because it is formed at 100 degree. So you are boiling the water at 100. This is water. Okay, you are heating the water at 100 degree. So the steam which is generated here, the temperature of the steam is 100. It is good, but only thing it cannot kill spore. If you want to kill spore, if you want to kill spore, you have to increase the temperature more than 100. You have to do the temperature 121. At 121 degrees, spores are killed. At 100 degrees, spores are not killed. So this method is not very useful. Frankly, there are no good uses for that. Okay, not very useful, but you should know that. Steam sterilization. Now, the ultra important, super duper important method is autoclave. Can I start autoclave? So can I start autoclave? The important method, the ultra important method is autoclave. You can see it's above 100. You can see it's above 100. These were the 4 methods below 100 degree. These were the 3 methods at 100 degree and finally above 100. Above 100. So autoclave. Have you heard about autoclave? What is autoclave? Acha, have you seen pressure cooker in your kitchens? In Indian kitchens, it's very commonly used. Huh? Have you ever done cooking or have you seen your mummies doing cooking in the kitchen? I guess everyone know what is a pressure cooker. So autoclave is nothing. It's a pressure cooker only. It's a modified pressure cooker. It looks like this. It is having a safety valve also, like the whistle of the pressure cooker. It is having a safety valve. You can see here. So you will say, what is the funda here? Why we are using a pressure cooker? To sterilize the objects. For example, this is my article and I want to sterilize it. Again, the article is having 5 things. The first 4 things are not giving any trouble. Bacteria, virus, fungus and parasite, you can easily kill them, but the 5th one, the spores are resistant. Now I want to kill the spores also. You can see it is like the previous one only. It is like the steam sterilizer. It is like steam sterilizer only. You can see here is the water. Here is the perforated tray. Everyone on the screen, can you see this is perforated tray? This is perforated tray. It is a tray on which holes are there, perforations are there, and below which the water is filled. You can see it is completely filled with water below that. And you started heating the water on a gas burner. You started heating the water on a gas burner. So whenever the temperature become 100, the steam is generated here. The steam is generated which is of 100 only. The steam is generated. Now put your article over the tray. This is my article. For example, this is my article. I'm putting it on this perforated tray. So steam will come upward from the perforation, from the holes. But you will say, ma'am, the problem is same now. If the steam is at 100, it will not kill spore. I want the steam not at 100. I want the steam at 121. If the steam temperature is 121, it will kill everything. It will kill bacteria, obviously, virus, fungus, parasite, but it will kill spore also. So is it possible to generate the steam at 121? Is it possible? Is it possible to generate the steam at 121? Say yes, say no. Say, ma'am, how it is possible? Water boil at 100, nah. Water boil at 100, steam created at 100. If you want the steam 121, if you want the steam instead of 100, you want the steam of 121 degree, you have to boil the water at 121. You got the funda. So we want to increase the boiling point of water. When the boiling point of water is 100, the steam created is 100 degree. 100 degree. I want the steam of 121 degree because 100 degree steam can kill the bacteria, virus, fungus, parasite, but not spore. I want to kill spore also. Just a second. I want to kill spore also. For that, I want 121 steam. So if you want 121 degree steam, you have to boil the water at 121. So how to increase the BP of water? How to increase the boiling point? Have you read physics in your childhood? Whenever maybe in your 8th or 9th standard, we do the numericals on that. In CBSE syllabus, it was there. How to increase the boiling point of water? We can manually increase the boiling point of water. How to do so? By applying pressure. Water boil at 100 degree, we all know, but at atmospheric pressure. You know what is the atmospheric pressure? At atmospheric pressure, this is the rule. If you give additional 15 pounds of pressure, 15 lbs, 15 pounds additional pressure, water start boiling at 121. So boiling point of water is directly proportional to pressure. Okay, at atmospheric pressure, it's 100. If over the atmospheric pressure, you are giving additional 15 pounds, water boiling point will increase. And rather than 100, it will increase to 121. If you are giving additional pressure. Okay, so autoclave is a pressure cooker. We are giving pressure in that. So can you see the diagram, what exactly we are doing? Everyone on the screen. I want everyone on the screen. I guess everyone can understand this diagram. Okay, it's a very easy diagram. You can see it's a perforated tray. Okay, and I have put, this is my article. I have put my article on this perforation. And it is filled with water. You can see this is filled with water. I'm heating it on a gas burner. So you can see the steam is generated. Okay, but you can see here there is the inlet. From the inlet, I'm putting the pressure. Extra 15 pounds per inch square. Please learn it. 15 pounds per inch square. So in this pressure, water will not boil at 100. Water start boiling at 121. So the steam which is coming here, it is of 121. And that steam will kill everything. This is the method. How many of you got it? How many of you got it? This is the principle of autoclave. It's very easy. In the books, you find it difficult. You don't. I think most of the students don't understand the principle, but now it's crystal clear. Got it? How many of you got it? Thank you so much. Thank you so much for your feedbacks. I'm very happy to read all these comments. Thank you so much. Thank you, Nidhi. Thank you so much. Because I will definitely schedule a session on that. Okay. Definitely, I will schedule the sessions on all these topics rather than saying randomly these topics in the comments. But I'm having a look on the comment box also. You can text all these on a contact number, which I will provide you at the end. So our team will coordinate and our team will schedule a session on that, and I will take the session. Whatever topic you tell me, I can take the session right now. The complete topics are prepared and taught hundreds of time to the students. So whatever topic you say, I just open it and I can just teach you, but only thing we have to schedule it beforehand and so that students can connect with us. Okay, so please text the topics on that particular number so that team can analyze which topic is in demand from the students more. So more and more students demanding the same topic, we will schedule in that sequence. The more demanded are scheduled first, and the less demanded are scheduled later on. But definitely we will schedule everything, don't worry. Okay, can we go ahead? This is autoclave. Everyone got it? Can we go ahead? So this is the principle written in front of you. So basically autoclave is a pressure cooker. Hana? So whenever we are increasing the atmospheric pressure, the boiling point of the water is increased. So we are increasing the boiling point from 100 boiling point to 121. So that steam is at 121 and it is killing. It is killing whatever present on the article. So there are 4 uses. You have to learn the 4 uses of autoclave. All culture media except culture media containing egg, serum and sugar. Because the culture media containing egg, serum and sugar is sterilized by Tyndallization and Inspissation. Got it? All the rubber ka jo bhi bana hai. It can be any rubber tubing or anything made up of rubber. All the linen, non-soiled linen, simple linen. It is not soiled. Just suppose I'm wearing an apron, the complete day I used it. Now I want to reuse it the next day. It is not containing any blood or any body fluid. Or the same with the OT gown. So next day we can reuse it after autoclaving. Okay, and all the surgical instruments. So please learn the 4 uses. Hana, for glass, it's not a good method. For glass, best is hot air oven. Got it? So please remember, for all culture media, autoclaving is the best. But for the culture media containing egg, serum or sugar, Tyndallization followed by Inspissation is the best. I told you this already. Got it? Got it. What is the control for autoclaving? The control for autoclaving, again, we have another bacteria here. The name of the bacteria is Bacillus stereothermophilus. The name of the bacteria is Bacillus stereothermophilus. The spores of this bacteria get killed at 121 degree for 15 minutes and for 15 pounds of pressure. The spores get killed here. So just suppose this is my instrument. This is my article. I'm putting my article inside the autoclave. But with that, I will take a packet. In that packet, I will put the spores of Bacillus stereothermophilus. They are commercially available. Close the packet and put that packet also. So put your article, put your packet and just start the process. So after 15 minutes, when the process is completed, there is a buzzer. You just open it. You, before touching your article, take out the packet and look for the spores. If the spores are killed, the process is successful. And the spores are alive, you have to repeat the process. You have to fix it. It is not successful. Say yes if you got it. Anyone have any confusion? Okay. So what is it? Holding temperature, holding time and holding pressure. The temperature here is 121 degree. The time is only 15 minutes. And the additional pressure you have to give 15 pounds per inch square. So please learn that. Listen, got it? How many of you got it? How many of you got it? Huh? Listen. We have to compare 2 things now. Let me ask you a question. Anna, so we have completed all the methods. We have completed the dry heat also, and we have completed the moist heat also. Everyone say yes. Everyone say yes. The dry heat is also completed. The moist heat is also completed. Among the dry heat, Anna, I told you 4 methods. The best among them is hot air oven. And among the moist heat, I taught you many methods, maybe 8 of them. But the best among them is autoclave. So let's compare hot air oven with autoclave. One is dry, one is moist. So you have to tell me 5 things of each of them. Okay. So here I'm taking hot air oven. And here I'm taking autoclave. You get maximum MCQs on these 2. Because they are the best one methods in the dry and the moist heat. Okay. Now first you tell me the principle of each of them. Okay, what is the principle? Number 1. Number 2, you tell me the temperature in each of them, holding temperature, holding time in each of them, holding pressure in each of them. Okay, you tell me the uses of each of them and you tell me the control of each of them. Who will tell me? Who will tell me? Start saying. Quick, fast. Who will tell me? Say, ma'am, principle. Here dry heat is there. Here moist heat is there. No, we know that. Okay, here hot air is generated with electricity and there is a fan to circulate. And here the steam is generated by boiling water, by increasing the boiling point of water. Okay, so here instead of generating the steam at 100 degree, we are creating the steam at 121 degree by increasing the boiling point of water by providing additional pressure. So this is the principle here. And here with simply, we are generating hot air with electricity. So that is the principle of each of them. Tell me the temperature. What is the temperature here? Quick now, you people don't respond. Chalo, what is the temperature? Say, ma'am, 160 degree. What's the temperature here? 121 degree. What is the time here? 2 hours. You can say 120 minute or 2 hour, whatever. 120 minute. Here only 15 minute. So you can learn here 120 minute, here 15 minute. What is the pressure? Say, ma'am, no additional pressure. Only atmospheric pressure. Additional is zero. But here we require additional 15 pounds per inch square. So please see the temperature, time and pressure. You get many questions on that. Okay, tell me the control of each of them. So control here the spores of a bacteria. The name of the bacteria is Bacillus subtilis and subspecies Niger. If you learn the subspecies also, subspecies Niger. And here the name of the bacteria is Bacillus. This is also Bacillus. This is also Bacillus, but it is another Bacillus. The name of that Bacillus Stereothermophilus. Okay, so spores of this. So spores of this bacteria get killed at this temperature and time, and spores of this bacteria get killed at this temperature, time and pressure. So these are used as the control. Now the last thing you have to tell me the uses, ultra important. You have to tell me the uses. Tell me 2 uses here and tell me 1, 2, 3, 4 uses. Tell me the uses, ultra important. Here all glass and all oily chemical. Remembering all oily chemical like dusting powder, grease, okay, all glass and oily chemical. Here the 4 are all culture media except the culture media containing serum, sugar and egg, number 1. Number 2, all rubber, okay. Number 3, all surgical instruments, okay. And number 4, all linen which is not soiled, because soiled linen will go in autoclave. It will go in incineration. How many of you got it? Huh? How many of you got it? What you are asking? Hot air oven, even more temperature, but why not able to? It killed the spore, na Amit? Both of them are killing the spore. This is also killing the spore. This is also killing the spore. Both of them are methods of sterilization. Please understand. Amit, listen. Here hot air is there. If you want to kill the spore with hot air, you have to give the temperature more. 120, 160 degree. But if you want to kill the spore with moist, like steam, even 121 will work. Both of them are killing. Because moist heat, na, imagine there is a hot air which is dry, and imagine there is a steam. Steam is also hot air. What's the difference between hot air and steam? This is also hot air, this is also hot air, but this one is dry, don't have water. Steam have water content in that. No, steam is moist. It is having water content in that. So the moist air is having more penetrating power. So imagine this is my article. It is having spores on that. Bacteria, virus, fungus, parasites are killed. I'm concerned with spores. So it is having spores. If I'm putting it in the hot air, so 160 degree is required to kill the spores. But if I'm putting it in moist air, moist air, that is vapor, that is steam, even 121 will work, because 121 have a better penetrating power inside the spores, and killing capacity is better. So I hope you got it. Both are methods of sterilization. Okay, Ji, can we go ahead? So we are done with all the methods. The Ultra 2 we have compared, and you get many questions on that. Okay, so heat is done. After the heat, I would like to tell you one more method here. Heat is done. We have seen all the methods, 4 of the dry heat and 8 of the moist heat. We have seen all the methods with the examples. Okay, now coming on the radiation. Radiation is one more method in the physical. Here, which radiation we use? Alpha, beta, gamma, X-ray. We use gamma ray. Please learn, it's a question. We use gamma ray, not alpha, not beta, not X-ray. From where we generated? So there is a machine. You can see inside which the gamma rays are generated from cobalt 60. It is already having cobalt 60 inside that. Inside which the gamma rays are generated. And there is no heat. That's why it is known as cold sterilization. Neither dry heat nor moist heat. No heat. That's why it's known as cold sterilization. Now this is my article. On the surface of the article, there may be a bacteria, virus, fungus, parasite. There can be anything. I'm putting this article in gamma rays. So gamma rays penetrate inside the particle, whatever particle it is, and damage the DNA of that particle. Once the DNA is damaged, that organism will get killed. That organism will get killed. Got it? So it is used. What are the uses of gamma rays? Basically, it is used for disposable item. The packets, the syringes are in packets. Catheter is in packet. The packet is sterilized by this. The syringe is the syringe, and if it is a plastic syringe or something, it will be sterilized by other method, but the packets of that is sterilized by this method, the disposable item. Okay, so plastic syringes, swab, all the disposable item, the packets also and the syringes also, I'm sorry. It is one time use. Now we know syringe we use one time and just throw it. So all the syringes, all the swab use one time, we do not wash and reuse it. Okay, the culture plates, we do not reuse them. The cannulas, the catheters, all the disposable items we sterilize by this method. Please learn. So this is the summary in front of you. I want you to learn. I want you to learn the summary. The summary is in front of you. Okay, so you get the questions on the examples, the MCQ questions I'm talking. If you have a theory question on anything, on any of the method, if you're getting a theory question, you have to write 4 things. Number 1, the principle. Number 2, the method. Number 3, you have to draw the diagram along with the method explaining that. Number 4, you have to write the examples. And if there is a control applicable, you have to write the control also. So if you are writing your theory question, if you're a second prof student or any student who want to write the answer in theory format in your university exam, so these are the points under which you have to write all the methods one by one. You can make a comparative table between them. Okay, but if you are preparing for any of the competitive exam like NEET, PG, FMGE, INICT, PLAB, USMLE, so you will get the questions and examples. For example, the first question, inoculation wires and loops, they are sterilized by which method? The answer is red heat. Answers are written in front of you. You have to just read this table. I told you red heat, है ना? You have to heat it till it look red in color. All the glass, whatever glass, कांच का हर चीज, syringe, petri dish, test tube, flask, है ना? Oily fluid, along with the oily chemicals, they are sterilized by hot air oven. Okay, all the disposable items, one-time use, disposable, they are sterilized by gamma radiation. All the culture media are sterilized by autoclave, but the culture media containing egg, serum, and sugar, they are sterilized by Tyndallization, followed by Inspissation. Okay, milk is sterilized by pasteurization, everyone knows that. Okay, all the soiled linen, the clothing containing the blood, it is contaminated with the blood or any human fluid, it is sterilized by incineration. Okay, and all the non-soiled linen, all the surgical instruments or the rubber, okay, they are sterilized by autoclave. So I hope everything is done. Say yes. Say yes. Okay. So this is all the methods, the physical methods I taught you in detail. Okay, we will solve some questions after this. Some MCQs. Are you people ready? You have to answer in the chat box quick. So sterilization in hot air oven. Tell me the temperature and time. I'm asking you the temperature and time for hot air oven. What is the answer? Be quick, be fast. Let me see who is the first one to answer it correctly. So be quick, be fast, be accurate. Speed and accuracy are the 2 keys of success. You have to be speedy, but you have to be accurate. Maintaining your accuracy, you have to be speedy. Yes, what is the answer? I'm still waiting. Come on, people. I'm asking you the holding temperature and holding time for hot air oven. I guess everyone knows. Yes, it is 160 degree for 2 hours. Absolutely right. The correct answer is 160 degree for 2 hours. Absolutely right. Okay, got it. The next question, pasteurization by flash method. What is the temperature and time? I told you the 2 methods of pasteurization. Holding temperature, holding method, and flash method. Tell me the temperature and time in both of them. In holding, the temperature is 63 degree, but the time we require is 30 minutes. But I'm very busy. I don't have 30 minutes. So I will increase the temperature by 9 degree. Instead of 63 degree, I will do it 72. So time will reduce drastically. Instead of 30 minutes, it is only for 15 to 20 seconds. So what they are asking in your question right now, they are asking flash. So look for this. So answer is 72 for 15. You are absolutely right. And if I change the question from flash to holding, your answer will change. In that case, you have to look for this. 63 degree for half an hour, but it's not given. Ideally, it should be 30 minutes. So they can ask you any of the method. You have to learn that. Okay, can we go ahead? The next question is in front of you. Tyndallization is a form of intermittent sterilization, pasteurization, boiling, or autoclave. What is the correct answer? Tyndallization is a form of intermittent sterilization, pasteurization, boiling, or autoclave. What is Tyndallization? In Tyndallization, we heat the article at 100 degree. At 100 degree for half an hour, 20 to 30 minutes. And for 3 consecutive days, day 1, day 2, day 3. So it is a method of intermittent sterilization. In Tyndallization as well as Inspissation. If I change the question to Inspissation, the answer remains same. So the only difference between Inspissation and Tyndallization is their temperature. Here the temperature is below 100. Here the temperature is at 100. Here the temperature is at 100. Okay. So here we are heating the article at 80 degree. Here we are heating the article at 100 degree. Here also we are heating it for 30 minutes for 3 days. 3 consecutive days. Here also 30 minutes and 3 consecutive days. Okay. Only temperature is different. Uses are still same. Both of them are used for culture media containing egg, serum, sugar. So best is Tyndallization. If it is not given, go with Inspissation. So we have revised it. Okay. Coming on the next question. Sterilization by autoclave. Tell me the temperature. They are just asking the temperature of autoclave. What is autoclave? Pressure cooker. It is a pressure cooker in which we are boiling water, not at 100. We are boiling the water at 121. To increase the boiling point of water from 100 to 121. At atmospheric pressure, water boil at 100. We are giving additional pressure, additional 15 pounds of pressure. So water start boiling at 121. Okay, so the correct answer here is 121. And you all are right. Okay, yes, this is best for spore killing. Absolutely right. Okay, so this all about the sterilization. I have covered most of the important physical methods of sterilization. Okay, thank you so much. I hope you learned a lot, enjoyed the session. If you have missed it, please watch the recording later on if you have joined late, because it is something you cannot afford missing. Whatever stage you are, whatever phase you are, whether you are a second prof student of MBBS, whether you are a paramedical student, whether you are appearing for your competitive exam, you are an intern, post intern, whatever. So this is a session you can't afford missing. Okay, so please watch it later on if you have missed it. And if you like it, don't forget to click on the like button before leaving it. Share the link with all your friends, colleagues, and batchmates, whosoever want to study the microbiology in the most simplest version in this world. Please share the link with them. Okay, thank you so much. And if you want the notes, there is a link given. You can see in the chat box, there is a link which is pinned. If you click on that, you will get all the notes of all YT sessions, YouTube sessions there, not only of this session. And these are free. You can see and you can distribute it. You can you can give it to your friends, colleagues, whosoever require. Here there is a you can see QR code. If you wish, you can scan it. I'm giving you time, or you can take a snapshot later on. You can scan it. If you scan it, you will be diverted towards our website. Our website is MedLive by Dr. Priyanka. You will be diverted there, and by doing so, you can connect with me on various social media platforms, that is Instagram, WhatsApp, Telegram. You can connect with me, where daily I share much of the educational content for all medical aspirants. I share many reels, I share many, MCQs, image-based questions, and some small concepts. So it will be useful for you. If you want to do so, you can do so. And there is the contact number also provided. You can note down if you wish. The contact number is 9321 001485. You can save it. It is only for chat support. If you have any query, whatever I am teaching, if you didn't find it, if there is any discrepancy, or if you want any topic to tell me which you want me to take it on the YouTube, you can text all those on this contact number. Thank you so much. Every Monday, Wednesday, Friday, we come live in the morning at 9:30. So today is Wednesday. Today's topic is done. Now Friday, on 29th of December, I'm coming with an important pathology topic. You can't believe hundreds of students have requested the same topic, healing and repair. So I am going to make a super fun for you. Okay, healing and repair. Autoquotes are scheduled, but a little bit later on. Autoquotes definitely I'm going to take. What about other? You can text it. Whatever topic you're writing it here, na coagulation pathway, definitely I will take a session on that, Amit. Okay, thank you so much for being with me, and consistency is the key. Okay, I guess everyone have heard the story of the hare and turtle, the rabbit and the turtle. Have you heard the story? Everyone in our childhood heard the story. So who's winning the race? It's not rabbit or hare who's winning the race. The race is won by the turtle. I mean, consistency is the key. Speed matters. I'm not saying speed doesn't matter. Speed matters, but more than speed, consistency matter. Sometimes you are too motivated. You study for hours and hours and hours. The next day you are busted out. You study zero. Worst technique. Rather, study for 8 to 10 hours, but the main thing, daily. Consistency is the key. Again, okay, thank you so much. Bye-bye. Have a nice day. Wishing you all the best. Okay, please share the YouTube links, my YouTube links and my YouTube channel link with your all medico friends throughout the globe. It's a humble request with all of you. Thank you so much.